head loss and flow rate to fluidize the filter bed during the backwash process are important considerations that we need to indicate during designing the water treatment practices. We are going to discuss the head loss and predicting the head loss for different filter media. But before we talk about the head loss, we need to know about the flow regime. So using the Reynolds number, we can identify the flow regime, and then we can apply the appropriate equation to predict the head loss through the granular filter media. So mostly the rapid filters, they are operating at the condition where Reynolds number is something between 0.5 to 5 and considered as the transition flow regime. When we are conducting the filtration process and we have accumulation of the particles on the surface of the filter, we have head loss. Another term that we are going to use is the filtration rate, which is the flow rate, water flow rate divided by area of the filter. Sometimes they call that superficial velocity, and the reason is that basically that's the velocity of water in the clean filter media. When Reynolds number is lower than 1, we have the Darcy's law. So epsilon equals to Kp multiplied by head loss divided by length of the, basically the depth of the granular filter media. But the problem with this equation is that it doesn't provide any relation with the granular filter media properties like porosity or grain size, and it doesn't provide any description about the porous media characteristics. So question, how we can relate the hydraulics to the properties of the media? So we can use this equation. This equation is for the laminar flow through the cylindrical tube, which is the head loss divided by depth of the filter, and it has a relation with the density of water, equivalent diameter of the grain, dynamic viscosity of water, considering the void spaces that present in the media and total internal volume, we can convert this equation to this one, that we have the specific surface area, we have the flux through the media, we have the porosity and density of water. Here kappa is the coefficient, this is the empirical coefficient, and this is some of the researchers reported kappa as 5, and several researchers reported that kappa is independent from the grain's characteristics. The later studies demonstrated that head loss basically is greater than value that was predicted by the last equation that we mentioned, this equation. So they found that the real head loss is greater than value that was predicted by this equation when Reynolds number is greater than 1. So this equation was proposed for the head loss when we have Reynolds number greater than 1, and it was mentioned that it accurately described the head loss for the filter medium. And even after that, some assumptions have been considered, like that media and fluid are homogeneous, and the other one was that the thermodynamic and chemical effects are small, so they adopted the Navier-Stokes equation to predict the head loss through the filter, and finally they got this equation to predict the head loss through the filter. And we have Kv and Ki. Kv is the head loss due to the viscous flow, and Ki is the head loss due to the inertial flow. We have some tables for Kv and Ki for different type of the filter, for sand filter, anthracite filter, and this is the approximate porosity. So we can use these values and plug in into this equation and predict the final head loss for a specific type of filter. So in this example, we want to calculate the head loss for an anthracite filter. The depth is 1.8 meter. We have the size of grain, which is 0.95 millimeter. In diameter, we have the filtration rate and temperature. So we can use this equation to calculate the head loss. So it has two terms. First, we calculate the first term. To calculate the first term, we need to know the Kv. No specifics are provided, but that's anthracite filter. We can use this table and just we select the midpoint. So Kv would be 228, and Ki we select the midpoint between 3.5 to 5.3 as 4.4. We have the porosity. So porosity, we don't have any information regarding porosity, so we just look at the table and select the midpoint. For anthracite, this is the porosity. So we selected the porosity as 0.5, and then dynamic viscosity of water and density of water, we find those for 15 degrees centigrade. And then we have the depth of the filter, which is 1.8 meter, and then we have filtration rate, which is 15 meter per hour. Porosity, diameter, density of water, we just plug in all of the numbers. So the first term would be 0.44 meter, and for second term it would be 0.06 meter. So the total head loss would be 0.5 meter. That's it for the today's session.